Hi ladies, it's Mr. O'Sullivan. Today we're going to be learning how to translate expressions from English to algebra. So today's learning target is I can write an expression by translating a sentence into an algebraic expression. So as you progress through this course, you're going to realize that we're going to be encountering a variety of word problems. So for instance, we're going to have word problems at least once every unit. We'll have to be able to decode them and translate them into an algebraic statement. So this is a video that I really need you to write down some of these things. So I want you to copy down this table. So I basically want you to rewrite all of this, all of that, and I want you to write down those phrases that are going to be popping up inside. Okay? So here's a quick cheat sheet that we're going to be using to help us translate these algebraic expressions. So before we move forward, the first things we're going to look at are addition phrases. So you know you're dealing with addition whenever you have something like this. We always use this operator. That's how we represent addition. So whenever we see these phrases, I want you to know that we have addition. So let's pay attention very closely. Whenever you see the word plus, add, more than, some, increase by, exceeds by, that's a sign you got addition. Here are some signs you have subtraction. You're dealing with subtraction whenever you see the word subtract, less than, minus, decreased by, difference, and subtracted from. And whenever you see those phrases, you're going to have the minus sign. You're always going to be taking away. Now, let's look at multiplication and division phrases. Our multiplication phrases are multiply times product and the word of. Whenever you see the word of, you're going to be dealing with fractions. And here are the ways we can represent multiplication. I can simply use a dot. I can just put them next to each other, which we saw in class. We don't typically use the symbol because it looks like an X, so we don't want to get it associated with a variable. Or I can just wrap both my terms in parentheses. That's extremely acceptable. Now let's look at our division phrases. Whenever you see the words divide, quotient, split up among, grouped, that's an example that you're going to have division. And there's two ways we can write division. We can use the divide symbol, or we can make a fraction, simply like x over y. All right, those are the phrases. You need to make sure those are written down. That way you know how to translate them rather quickly. Let's go on to the practice. All right. So here are some less than tricks. Whenever you see the words less than or subtract from, it changes the order. So whatever you read first actually comes last. Whatever you read last comes first. So here's a nice trick that my friend Shelly told me about. Whenever you see the word from, write this down. From comes first, which is right here. From comes first. Parentheses are always going to be needed when a number is multiplied to a sum or a difference. So whenever you see sum of and difference of, there is a very good chance you're going to have parentheses. All right? Examples. Define a variable and write an expression for each phrase. So when we mean variable, we just simply mean let's use the letter X, Y, Q, whatever. I'm going to use the letter X because I like X. So we're going to be writing an expression and we're going to be using X for each one because as I said before, I like the variable X. You could use a different variable, but just for transparency and consistency, we're going to use the letter X, variable X. So I approach this a little differently than other people approach it. Some people just go right into it. I like to take it very slowly. So what I do is I basically do like a close read of the problem. So I mean a close read, I mean we really look at it closely. So we read it 1 or 2 times. So 7 more than a number. 7 more than a number. And what I do is when I say that to myself, I sort of like put a picture in my head and then I'm like, you know what, I really have to get this onto the paper. So I know that numbers are important, phrases are important, all that stuff is important in Algebra 1. So when I see the word 7, I need to think of the number 7. And before we said more than was addition. And the number, we don't know what the number is. Whenever we don't know something, we always just put the variable x. So I can say this expression is really just 7 plus x. And that would be your final answer. We're not solving anything, we're just rewriting it. Now in our next example, we have 23 subtracted from a number. Here's the issue. We don't know what the number is, so we're immediately going to put an x. Remember, we said before, subtracted from comes first. So I'm going to put my x first, and I'm going to put my 23 second. So I'm really doing x minus 23. Now for number 3. I have 2 more than twice a number. 2 more than twice a number. Well, I have the number 2. I'm going to use red this time. I have the number 2. We said more than was addition. Twice is like basically multiplying. So I'm basically doing 2 times something. So 2 times the number, which is x. So I can just rewrite this as 2 plus 2x. And that's your final answer. Try to do number 4 by yourself. For this example, when I have 7 less than 3 times a number, we said before that whenever you have less than or from, those come first. So I need to do my 3 times a number first. So 3 times a number is simply 3x, and then I just take away 7. For number 5, twice the difference of a number and 3. Well, I don't know what the number is, so I'm going to do an x. Difference of is subtraction, so I'm doing x minus 3, and I'm doubling it. So I'm doing 2 times x minus 3. And that would be your final answer. Because remember, we said before, difference of, sum of. These are key phrases you need when you want to look at parentheses. So you're going to be doing parentheses whenever you see sum of and difference of. The quotient of a number in 8. Well, we know that quotient means division. And it's a number and 8. Well, my number is x, so I'm going to do x divided by 8. And that's your final answer. The sum of twice a number and the square of the number. Well, you're not distributing anything to your sum, so you actually don't need to put parentheses around it. Well, twice a number, you have to say, is basically 2 times a number, so 2 times x or 2x. Sum is addition. The square of a number, we might not have necessarily said this before, but the square means I'm raising it to the second power. So x to the second, or x squared, or x to the power of 2. So I'm really doing 2x plus x squared. And that's your final answer. Now, 9 times the sum of 12 in a number. Well, I have the number 9. Sum of means parentheses 12 and the number. Don't know what the number is, so I'm going to do 12 plus x, so 9 times 12 plus x. And again, you can distribute and simplify and get a nice answer. So number 9, if n represents a number, write an expression that represents the difference between a number 1 larger than n and 1 smaller than n. So, n is my number. Difference of is subtraction. A number 1 larger than n would just be the next number, so n plus 1. And 1 smaller than n would be 1 less than n, so this would be n minus 1. And I want to represent the difference, so I want to do m plus 1 minus n minus 1. The thing is, I need to make sure I distribute this negative to each term. So I really have n plus 1 minus n plus 1, because a negative becomes a positive and a positive becomes a negative. So when I do this example, I'm going to combine my like terms. N minus n, they cancel each other out. 1 plus 1 is 2. That's your final answer. Number 10. If S represents Sally's age and her father is 4 years less than 5 times her age, write an expression for her father's age in terms of the variable S. Well, S is Sally's age. Her father is 4 years less than 5 times her age. Well, we know 5 times her age is going to be 5 times S. going to do a script S. Less than means my 5s comes first, my 4 comes next, and I want to take away 4. So Sally's age, if S represents Sally's age and her father is 4 years less than 5 times her age, then her father's age is 5s minus 4. And that's your final answer. Try to do number 11 and 12 by yourself. Okay, let's go over number 11 and 12. In number 11, if n represents a number, then write an expression for 7 less than 4 times the difference of n and 5. Well, I know that the difference of n and 5 is n minus 5, and I want to multiply it by 4. And remember, less than, we switch our order, so for number 11, I get 4 times n minus 5 minus 7. And then for number 12, if x represents a number, then write an expression for the sum of twice x with twice a number 1 larger than x. So I know the sum of means addition. Twice x is 2x. And I want to add to it 2 times a number 1 larger than x. One number larger than x is x plus 1. So I'm going to multiply it by 2. So I get 2x plus 2 times x plus 1. And that's your final answer. If you have any questions, please email myself or Ms. Jimenez or Ms. Townsend. Make sure that you have a reference sheet of those phrases in the beginning of this video that go with addition, subtraction, and so forth. Have a great day, ladies.